First, make sure you are registered to vote in the upcoming election, even if you were previously registered. Second, mail-in ballots can be dropped off at your local county election office instead of returning by mail. Follow all ballot instructions carefully to ensure your vote counts. Third, some Pennsylvania counties are opening satellite election offices or drop-off boxes starting September 29th to provide in-person early voting opportunities before Election Day. The most important thing we can do right now is educate those outside of our industry about sustainable design and how to care for the environment. The best way to do that in these days is through social media. Follow AAA Philly Coat on Instagram and LinkedIn for more information and to help spread the word. Our planet is on the ballot this year, so we need everyone to get out and vote.
All right, so how are we doing on attendees? Okay, so we'll just give it a few more minutes for folks to join in. So if you're just joining, if you would just enter your name and your email address into the chat box. Everybody should be muted in here, but we've got 3 presenters for tonight. Tonight's topic is on net zero buildings, and this builds wonderfully upon many of the sessions that we've done over the last several months. I'd say probably starting back in July when we had Kim Shen with TLC talking about demystifying energy modeling. And then we've run through environmental design tools for architects, sort of best practices or environment 101 in our high performing projects that we did last month. And then this month, which is really focused on 3 amazing case studies of how you get to net zero buildings. So as we've done in the past, we're going to be building up in scale, starting with a small project going to, which is going to be Jeremy Avellino with BrightCommon here in Philadelphia. Jeremy's going to be presenting on the Creek Road Passive House project. The mid-scale is going to be Jason Jewhurst. Jason is a principal with Bruner, Cott. Oh, and Jeremy is the founder of BrightCommon. Jason is a principal with Bruner, Cott in Boston. He's going to be presenting on the Hampshire College R.W. Kern Center, which is a living building challenge project, which also gets you net zero compliance with that. And then the large scale is going to be the United Therapeutics Unisphere project by EwingCole, and Jennifer Wampler and Jason Fierko are going to be presenting on that. Jenn is an architect and Jason is an engineer, so they'll give both sides of that equation for how an integrated design process worked within that particular project. So again, if you're just now joining, if you'll just enter your name and your email address into the chat. As we are going through each of the 3 presentations, you can plug your questions into the chat as well. We're going to do a Q&A of all 3 projects at the end of this. We're going to take about an hour, 20 minutes per project to run through each of these. And then the remainder of the time will be an open Q&A to our panelists. Again, thanks to Jeremy Avelino with BrightCommon, Jason Jewhurst with Bruner, Cott, Jennifer Wampler and Jason Fierko with EwingCole. And with that, I will stop sharing my screen and let our first presenter, Jeremy Avelino, go. Also, tonight's session is being recorded, which we'll be sharing now.
How are we doing? Can you see that?
I can see that.
And can you hear me?
I can hear you. I can see you.
2 for 2. Well, thanks, David. Really appreciate being here. And I just wanted to start by saying Happy Indigenous Peoples Day. My name is Jeremy Avellino, and I'm a South Philly Italian-American settler, born in Philadelphia, raised in Delaware County, in the traditional lands of the Lenni Lenape. And I'm happy to be here with you. I run BrightCommon, a sustainable architecture practice here in Philadelphia, and we have a simple slogan. And hold on, let me see if I can do, there we go. High concept, low carbon, all people. So we're designing buildings in the hope and belief that we can play a role in the decarbonization of the built environment, actively participating in fossil fuel divestment. And when we're doing our best, I actually believe some poverty eradication through our passive house and affordable housing work. So we want to spend the next 20 minutes delving into a project called Creek Road Passive. It's a pre-certified passive house under construction in the suburbs of Pennsylvania. It has a goal of source zero energy, possibly net positive energy, depending on how many solar panels we can get in there, and a rigorous focus on low embodied carbon construction. So we usually talk about our work being rooted in climate change adapted urbanism, but most of our work is within the cities and most of it is within Philadelphia, but this one's in the burbs out near where I grew up. So I'm gonna try to call it climate change adapted suburbanism. And that made me think about something is, the question we're trying to answer with this project is, can the most unsustainable human settlement pattern ever invented by humans be redeemed for a post-carbon near future? And the reality is, not can it, but how do we do it? Because people aren't moving away from the suburbs, they are flocking to them. And we need to figure out how to actually make these places sustainable. So I hope we have some answers for that. I'm not going to talk about transportation. I'll leave that up to another expert. So let's start real quick. I just want to assume folks know about passive house and low carbon and things like this, but I just wanted to quickly talk about the anatomy of a low carbon passive house, just to get it back on your brain. Six strategies: continuous super insulation, thermal bridge free construction, the building envelope has to be airtight, high performance glazing, balanced heat and moisture recovery ventilation. We usually say that's an ERV or an HRV. And we want good orientation. We want a fabric first approach to optimize gains and minimize losses. And we do that through the use of hygrothermal modeling, usually through WUFI passive. So let's talk about embodied carbon for 30 seconds. I want to talk about something. Well, first I want to say that it matters. And I want to talk about a great book that I hope you all have. If you don't, you should buy it. It's called The New Carbon Architecture. And it's a series of writings that are really brilliant. And this graph really struck me. And this is about the time value of carbon. And it's really the top one I want to talk about here. Basically, when we emit carbon matters more now than ever. And that has everything to do in the materials we choose to build our buildings with. So carbon emitted today has much more impact than carbon emitted after 2050, this magic goal, or 2040, maybe that's your goal. 2030 is a whole other goal, but that's why we're at this meeting. So the new zero is actually not necessarily zero energy, but zero carbon, both embodied and operating. And so we primarily try to work with wood in the homes and apartment buildings and mixed use projects we design. And wood buildings actually have the chance to sequester carbon within their manufacture, somewhat like a tree. And something like softwoods are something like 50% embodied carbon, and from what they've sequestered with the tree growing and actually sucking this out of the air. So a ton of carbon in a building actually represents about 3.67 tons of carbon dioxide absorbed from the air, right? So if that doesn't make any sense to you, buy that book. It's laid out in really simple terms. I think anyone can understand. And the way we think about, the way we want to mentalize architecture is to consider building it out of sequestered carbon and thinking about this in a way of becoming carbon conscious with everything we think of. So yes, we want to think about concrete, we want to think about wood, we want to think about everything, but really we want to think about things that actually sequester carbon out of the air. And a lot of that has to do with forest management, when to cut down trees, when to grow new trees and whatnot. So that's part of a larger conversation. Great book, I said, highly suggested. So let's get to the project. This is the context. This is the site out in Kennett Township. And it's great when your client has a drone and loves to use it every day. It's a very steep site. There's a huge grade change from the bottom right of the picture to the top left. We removed an old house from the site that was not working for the clients anymore. And we needed to keep the new one in the same position to not trigger a lot of stormwater management costs. This was our precedent image. This is a Shaker barn, the church family frame barn. And I love this image because of how idiosyncratic it is. Just the one window off center kind of, and the hayloft entry off center does it all for me. But this was it. It's about simple massing, simple shape. The client was really in love with farmhouse architecture, so we just kind of went with that. And this is the this is the concept rendering. So the concept that we're playing with here is actually I don't know, it's not like a farmhouse. I mean, at best, he's a gentleman gardener, right? Everybody loves this aesthetic, but he's not a farmer. So what we're thinking about here is actually it being the carbon farmhouse. Can we actually create architecture that farms, if you will? I guess it would be harvesting carbon out of the air. And one thing they talk about in that book is buildings that are actually made of sky, and I really love that. And we want to pay attention to a fabric first approach where we're orienting the building due south on the long axis, paying attention to a good window to wall ratio for passive solar gain, but keeping it far enough away from the trees so that we can actually get the solar gain, but not too much so that we don't need expensive shading. It's compact enough in that the only portion that is the passive house envelope is this compact little house here. We separated the garage and we separated this sort of 3-season room that we're calling a winter room, where he has a wood burning stove outside of the passive house envelope. So how do we build it? How do we do houses like this? Can you stick frame it? Of course you can. But anyone who's tried to stick frame a passive house knows how difficult that is. And so we were approached on the project by Steve Hessler and Elke Cassidy from Holtzrum, who do this amazing system that they labeled Holtzrum, which literally means wood room in German. And this is the diagram on the left, and this is the actual sample in the factory on the right. And it's a really wonderful system. We're a little short on time, so I'll just say Google Holtzrum. They're amazing. I'll give you the information at the end of the presentation, but we really, really are in love with this system. So they have a deal with Blueprint Robotics, a factory in Baltimore, where they make a series of different wall types for different markets. And this one is kind of their passive house market. And what's wonderful about it is it focuses on low embodied carbon, right? And we'll get to that in a minute. But basically everything is wood, from the studs, from the framing, all the way through to the insulation. And that makes a huge deal in the embodied carbon content. But what I like about this process is that it's our first panelized process made in a factory. And this place felt more like IKEA than it did a job site, and it really feels like that. Like they have 40-foot long studs, and they're clean, they're clear, they're amazing. And so, yeah, this is where they process beams. This is how they frame, right? Some of you are familiar with prefabrication and panelized systems. This isn't your sort of 1970s deal where you're laying it on a table and guys are just, whacking nails into the side. It's all done through CAD/CAM software, and there's one person usually operating each station. They tilt it up, add the wood fiber insulation, add the plywood on the backside, and add the which is where the sheathing and air tightness layer is, and then this is the outside that gets their water resistant barrier and a wind tight layer. And the windows go in too, which is amazing. Stack them up like Legos, and then these get put on a truck and come to the site. It's really, really ridiculously efficient and clean. One of the best things about this, one of the hardest things about a passive house is actually getting the windows installed on site. So one of the best things about going panelized is they airtight. Each panel is pre-airtighted and the windows are pre-installed. So we have these wonderful Zola in-swing tilt-turn triple pane windows, pre-gasketed on site with no foam, or off-site with no foam, so they come to the site just like this. And this is it. Tractor trailer shows up, and the lull pulls each piece off, and they have a series of these deliveries. COVID definitely posed a major challenge and a major interruption to this project, but BPR Blueprint did the best they could. There were definitely interruptions, but they rolled with it. And there's some oops moments. This is a sort of thermal bridge detail where they overlap the exterior wood fiber insulation so that you don't have a thermal bridge there, but you should not be strapping these load straps onto that. So stuff happens and we deal with it. They rolled with it and fixed it on site. but everybody's learning. This is a plan view, drone view of the actual site, and I think this is the at the second floor, and this does a good job of showing how we separated everything out to have a good heat loss form factor. So what we want in Passive House is to have a very compact building shape, a very simple building shape, and if there's appendages that break that thermal barrier or complicate things, it gets very difficult to actually hit zero energy. So we physically separated the 2-car garage that's fully outside of the Passive House envelope. That was a very easy move. That makes sense anyway. You sort of enter the house through this cut in the site. And this interesting winter room where the client really wanted a wood stove. You cannot do a wood stove in a Passive House without causing major issues. So it's outside of the Passive House in this sort of screened-in porch with, I think these are even single-pane windows, you know, and that's where he gets to, you know, burn wood, all the wood he wants, right? So again, more of an accoutrement than anything. And there it is. This is sort of the, you know, coming up this really steep slope. This is the north face. So there's fewer windows here to keep that heat in. The garage, the main house, and the winter room back here in an existing sort of shed. This is the south face. So solar panels up here. Eventually he wants to put solar hot water on the garage roof. But again, just getting it just far enough back from this tree canopy through a solar shading study, so that and just close enough, so and tuning these windows in multiple iterations of Wolfie Passive with Ilka, who is just so good at it, so that we could avoid costly, you know, items like additional solar shading, which really tend to hit a budget really hard. So we're always trying to tweak things to avoid extras like that, if you will. And this is sort of from the east, and this is just temporary tarping, but this is the roof deck there in the winter room. And this is a view on top of that roof deck, right? So this sort of thing, it starts to get immersed into the woods. It catches some early morning light. His bedroom is here. I think one of the things that was really interesting and challenging was how to, you know, we play around with a lot of different ways to sequence building projects, obviously, but one of the challenging things is you can't really have the airtight layer or the thermal layer interrupted when you're moving to from the Passive House envelope to a non-Passive House envelope. So we had to pay a lot of attention where this entire wall gets bolted through the exterior insulation. We end up having to use a different kind of insulation there that's much more dense and can actually take the crushing loads of through bolting, so that you only have a series of point thermal bridges, which are tolerable within an energy model. This is the makings of the wood stove chimney, and that had to get site framed on. Here's a good detail of it after the fact to receive a 12-inch stovepipe, and it's all non-combustible construction. And what was fun was in the design process, we actually had to, you know, get in here, and this panel came on site and has all kinds of blocking and special thermal bridging in between here and the wall that kind of handles the connection there, so that when they're ready to frame it on site, it's good to go. It's a little bit of coordination there at the end because they switched up the veneer stone on the chimney, but we ended up figuring it out. And here's what we always want, is the verification from FIAS. It's a pretty intense back and forth with, you know, a very small nonprofit located out in Chicago. It feels like a whole other version of working with L&I, and they're really great to work with. They really care about this, and it's great to get, the sooner you can get an energy model in early, the better, because there's about 4 rounds to go through with FIAS, so it definitely takes time. I think it's in terms of working with FIAS or the international version, the Passive House Institute, we've worked with both. I tend to have a preference with FIAS when it comes to residential projects. I think that there's some interesting different methodologies about how the energy modeling systems work. But I actually like that the climate specificity of FIAS and working with their customer service module seems to be a little bit more efficient. So, and we really enjoyed how that turned out. yeah, so here's some of the more nerdy stats, but we were just happy to hit it. I mean, it actually, you know, you end up kind of getting ahead with the design process, and you're waiting, you know, you definitely get some like feedback early on, but you've really got to start motoring with permitting, and then hanging out there is the pre-certification. So I think that's one of the lessons learned, is you kind of can't wait to get pre-certified and then start doing construction documents and then apply for a building permit. You'd be in this for 5 years. So we have to, I think what we're learning as a studio is how to do early iterations of energy models so that we're going to land in the right place. Wolfie Passive, I don't think is the best version for that. We're still looking for a good energy modeling software, whether it's Cove Tool or Sapphira, to be able to do earlier models that can talk about energy use that are more schematic and iterative in nature, versus Wolfie, which is a really complex deep dive into the energy use, and it's a little hard to iterate with it. And then here's some of the stats. It's a 3-bed, 3-bath, single-family home. The passive house envelope area, that compact building shape, is just under 2,000 square feet. I think that constitutes as a small home these days. I'm not really sure what's small anymore. I think that's on the smaller end. The winter room adds another 318, but again, that's outside of the envelope. And then the clients wanted a garage, which is unconditioned and also has a workshop mixed in there. And that's another 1,133 square feet, which is about the size of my house. So the construction cost started off at about $275 a square foot. I think we're kind of rounding out at about $300 a square foot now that we're getting into finishes and whatnot. That was the last estimate I got. Have we built passive houses for less? Yes, I think the contractor really took a hit on it, trying to get it done. I think that for the quality of construction, I think for the speed outside of the pandemic, of course, and I think for the precision, I think that this is a really great price for carbon consciousness, true low embodied carbon, and I believe with the right amount of solar panels on that roof and the right behavior from the clients, actually net positive energy in terms of like the operating energy. So I think that, you know, $300 a square foot is actually a pretty good deal for that. Right, so the goal is source zero energy certification. So we have that pre-certification, which is we're really happy about. Great team. The builder was Hugh Lofting Timber Framing. Again, the panelization, we worked really well with Steve and Ilka from Holtzrum. And they're the folks that coordinate with Blueprint Robotics that kind of translate the architecture, our Revit work, into a separate software, which then goes to Blueprint and runs those machines. Like we talked about, the windows are Zola. We love Zola windows. We've played around with like less expensive windows than Zola, and some are okay. We've gotten hurt on some projects with some not so great passive house windows. You got to be careful. I think you've got to really at least Zola, Alpin. There's sort of a mid-range quality there that I think ought to be the low end in these kinds of projects. Heating and cooling. We could have done this with air source heat pumps easily. The client who works as a mechanical engineer was really just obsessed with having a ground source heat pump, and I'm so happy about that. I think it ended up being more money. We kind of didn't need it. The smallest one they make is a 3-ton system, and I think we only needed like 1.25 tons for this whole damn house. So, but it is truly a much more sustainable way to do it, and he was willing to actually spend that money, and I'm really happy about that. Ventilation is Zender Comfo Air ERV. The kitchen exhaust, I could spend another 20 minutes on, but whether to vent outside or not, we decided to vent outside and have makeup air. And the hot water is a 50-gallon heat pump water heater, which we're just really in love with those. And I think that's about it. I could say more, but I'm down to, oh, that my alarm. There goes my alarm.
There goes your alarm.
How about that, man?
Thanks, Jeremy. I also put in the chat the video that the recording.
Can I play a 30-second video?
Yeah,
I
30
forgot my
seconds.
video.
I also put in the chat our recording of Holstrom presenting at our last coat as well.
Oh yeah, excellent, man. So I blew through this and then I forgot. This is sort of a requisite video, time-lapse video. The panel's going up. It's 30 seconds, so bear with me. right? So the first floor is up, that's the winter room in the back. And this is it, then lifting it up, and you'll see that they have to sort of like, to make the air barrier continuous, they have to sort of like lay these plastic sheeting bits over that eventually get taped up on the inside there. But once the panels were on site, you know, they can get a whole floor up in about a day, or a couple hours even. So with about a crew of 3 or 4. All right. Thanks, everybody.
Thanks, Jeremy. That was great. So if you have any questions for our panelists, just enter that into the chat and we will do Q&A following all 3. So Jason Jewhurst, you're up.
Thank you, David. Jeremy, that was fantastic. Thank you. Really tough to follow that level of detail. And I love the story of the Shaker house. Actually, we're going to go to another place in New England, or a little further up north. It's not that far away from the Shaker world as well. Just bear with me and I'll share my screen. All right. Well, good evening, everyone. My name is Jason Jewhurst. I'm a principal at Bruner Architects. We're a mid-sized architectural full services firm based out of Boston, Massachusetts. We've been around for about 48 years. We specialize in campus architecture, multifamily, and cultural projects, not only regionally, but sometimes we work coast to coast as well. I'm going to talk about a project that was finished in 2017. And it's in the part of New England that it's in. It's a wonderful little enclave, and sort of building on the story of you know, thinking about regional architecture that pulls cues. But first, I just want to say a little bit, like, Bruner Cott didn't do the work all by ourselves. We spent you know, 2 years working with a robust team of engineers, consultants, thinkers, disruptors, troublemakers, builders. I would say that to the credit of the college, Hampshire College, really, you know, they brought on the contractor before they hired the architect for this project, which I think goes to the level of thinking that they do when they think about bringing collaboration to their campus. And I'll talk a little bit about how it touched on our process for this campus building. And first, I'll start with an overview of the Kern Center. And then I'll go into a deep dive on the energy process and the energy design, as well as water, and how our approach to regional materials unfolded throughout the project. It is a living building, certified building. When we started this journey back in 2013, there were, I think, 4 living buildings on the planet. The Kern Center came in at number 17. I don't know if I'm sure many of you are familiar with this framework of thinking and building performance tool, but it is taking charge across the world now. And what we're seeing is that there's really thinking about regenerative architecture in a manner that starts to flip the diagram from thinking about how do we reduce to how do we actually create something that regenerates and restores. So I'm going to talk a little bit about how the Kern Center and the thinking went into the philosophy behind some of the design strategies that we came up with our team. Just a brief overview. If you're familiar with living building, you'll understand. There's 7 petals. These sectors sort of bring together. We like to think of it as the 2 halves of the brain. You have the more technical side and performance side, but then that melds with the softer side and the biophilic nature and equity and beauty of architecture that is our responsibility as thinkers, architects, and engineers and owners. So this is a view of campus. The Kern Center is situated at the heart of campus. This campus was built out in 1971. It was a time in the world where electricity was too cheap to meter. Embodied carbon wasn't a topic or even really a consideration. And this campus was basically an electrified campus that was built. It does now have additional gas services for the buildings, but it really represents that heroic modern architecture that unfolded throughout New England. And the Kern Center, just a high level, it's a 17,000 square foot, 2-story building with a full basement. It houses the admissions program, new student learning programs, learning spaces, an art gallery, and really the main functioning, it's the new living room to campus as people come and go as they arrive to campus. A little bit about our process. Now, Hampshire College is a collaborative group. We met with the students all the way from the administration and President Lash, Jonathan Lash, all the way down to students coming on campus for the first time. And after that process in schematic design and programming, we developed this process we developed these 9 goals. And through the 9 goals, they came to us with the idea that they really wanted to hit Living Building Challenge straight on. They felt that that was a performance criteria that really spoke to them. And what they asked of us, though, is that we do it in a way that respects and reflects Hampshire's values and embodies their culture. And thinking about architecture, it was really important for them to have the building feel like it belongs to its context and it is rooted in its place. So that's a theme that we're going to talk about throughout these next 15, 20 minutes. But that was a really great place for us to start, where we were all working from one sheet of music at the beginning of the process. And we used that to help us make decisions in the future when, cost per square foot, construction methods, weather, delays, increases in different costs come into effect. Now, New England this is actually what New England looks like now. This is Hampshire campus. They're basically in the middle of the Pioneer Valley. It's a beautiful place. They have 800 acres of land, and they're surrounded by land that's also protected in a conservation trust. And you basically look and you can see off into these rolling hills that are that's the notch of the Holyoke Range. And getting back to our 1960s, 1970s campus, they only built out about a third of the campus. They have some housing that sort of rings around the campus, and then they have this small academic core that has their science buildings, an athletic building, a library, a food commons, and other classroom buildings. But you can see that this main road that comes up, it doesn't feel like a New England campus. It feels more like an office park, has a flagpole and the center drive around it. It just feels quite disconnected from the campus, or the feeling when you walk on Hampshire's campus. So in plan form, looking at the site, this was the site that they had designated, and we worked with them to say, you really need to build out the core and think about the Kern Center as this. It could be a catalyst to bring people more into campus and thinking about what could we do and how could we site the building to help reinforce that. And this is funny, like after 3 months, sort of from an architect's diary, we sort of raised our hands and we're in a meeting with the president and several other, sort of key stakeholders. We said, guys, we just don't think it makes any sense to put a building with roads all the way wrapping around it and you're trying to build a living building. It just doesn't, so can we take some time and maybe step away from programming the building and do a mini campus plan and start to think if there are other things that we can unlock to help free this siting challenge that we have. So it felt like we were going to add a building to campus, but not really help densify the core or make it feel more complete. So the president raised his hand. He said, look, I know it's risky. That makes a lot of sense. He's like, actually, and what he said was, Jonathan Lash said, look, I'd really like to get rid of that fossil fuel spear from the center of our campus. And I don't like having buses idling every hour. So what can we do to help reinvigorate the campus after 40 years? This is something that they were very interested in. So we focused on this main circulation road and said, okay, so if we begin to say, like, what if cars didn't come to campus anymore in that way? And we shifted the road to the north, removing that road. This is before we even started designing the building. And then we pulled the building closer to the campus core to create that more college New England feel with these smaller spaces. And that began actually the project before the Kern Center was this road project that we did the summer before. And we shifted the road to the north and we reopened up this entire center space and gave it back to the pedestrians and students and turned it into a prairie. sort of I would say that was a pretty big milestone for the project, because it turned into not just the building they're going to add and have that be their welcome pavilion to campus and really connect people to their community, but it became about reinvigorating their campus after 40 years. So once we figured out how the site could work, we did the road project, we shifted it to the north, we gave all that green space back to landscape. We had a nice canvas now that we could work within. And you could see, if you could imagine the road just coming up and turning around those brick buildings, how different of a feel that is. So just a quick overview of just what the project and the programming is. That on the east and west, we have these stone anchors, which really house the admissions program and student programs, classrooms, learning spaces. And in the center, we sort of accentuated along the axis, shifting so that a lot of the building is facing south. And you'll see that the footprint of the building is quite narrow. We're about 40 feet wide. And I'll talk a little bit about that with daylighting. And what that did, it just allowed us to sort of open up and celebrate along that south facade that faces campus, but maintaining a nice high level of transparency so that people could feel welcomed as they come to campus on the north side of the building. So as you arrive, you're ushered in through, and this is almost a mixing box that you can mix with students, get a cup of coffee, come in and sit down and take a moment. If your student is coming for the first time, or if they've been there for a couple of years, this becomes that place where everybody could meet on equal playing field. And it became a good party for us to experiment with using the campus as a backdrop. The building, the Kern Center, I'll talk about the materials. This is a mass timber construction. It's a Nordic lamb product. The engineered glue lambs all came from Ontario, Canada, and they were machined and tooled in New Hampshire and then fabricated on site. And I'll talk a little bit about how it all came together. But the other part about our material palette was thinking about how do we use the campus as a backdrop as well? Because that was one of the things that after our first day on campus, that when you go into their buildings, you get separated from those spaces, you get separated from the environment, the region that you're in. So we wanted to have this viewing box that you wouldn't be separated from nature at any time. You could always look back to campus, have a sense of connection. And then as you go upstairs into the second floor, you have that same so there's double height spaces on either side of a bridge. And that's our art gallery for the students to do their final projects. And it becomes a really highly animated space during different times of the year for celebratory projects that students are making with faculty. And again, you have the two anchors on east and west that are more solid. They have long, high, tall windows that allow for the daylighting to happen, and they'll show some views of that too. But more importantly, what we were able to do by bending the architecture along that south axis, we were able to open it up to the views on campus. And this became this concept that we started thinking about, which was the inside out spaces that we create. So whether you're in a classroom, you're walking down the hall, you're in a seminar room, or you're working as one of the faculty and staff in the building, you're always able to find that view back to campus. And it is just a beautiful, remarkable campus. And we felt that that was sort of that was another ingredient or a player in the room that we wanted to make sure was highlighted all throughout the architecture, and that actually the building became a backdrop for the landscape itself. And down in the basement, where I'll get into some of the details, so this is where our water systems are. This is where our energy systems are. The building is fully net positive in energy and water design. We don't mix any human waste with water. We have a composting system, and I'll talk a little bit about those decisions that went into that. We have an indoor gray water treatment system. I'm going to show you how we developed that system as a pilot program in the state of Massachusetts. But we also have some other things that I'll talk about. There were some stumbling blocks that we had along the way. And I'm going to kick it off with energy because there's a lot to get through. So I can't stress enough, 100% what Jeremy mentioned earlier is energy modeling early and often, and use it as a tool. It shouldn't be something you're using to record your design. It should be something that you're pulling ideas from, and it's testing how you begin to make either the massing or develop the programming. So we decided, we went through the process, and in New England, in this part of New England, 1 story, 2 stories, you have a lot of energy that you could generate for those floors. But as you get taller and taller, you got to squeeze the EUI lower and lower. So we felt because the building didn't need to be more than 2 stories, the massing was just right for the campus. We focused on that and we set within these targets. And we said, okay, so let's set our EUI in that 23 to 19 range. And we know that it's a campus building, it's not going to be used like a residence. It'll probably be used 18 hours a day, so we should plan for that too. So as a measure of thinking like, okay, so how to use the architecture as the ingredient, as one of the ingredients that drives your energy model? Well, our roof that unifies the 3 pavilions underneath, you have the 2 anchors, the stone anchors on the edges, and then you have this middle space that's very animated and transparent. Well, the unifying roof that sort of connects all 3, that's our capacity. That's what we can generate for water usage, and that's what we can generate. That's what we'll have to use for energy as well. So throughout the process, during design development, during CDs, we kept checking in on these models and working through what our capacity was. And we knew that if we ever got over 6.6 kWh per square foot, then the game was over, right? So we had to go back and retool our systems and our walls and our performance of, window to wall ratios and how much solar shading to really make sure that we stuck within this hard deck number, because that's what our size of roof could generate in New England. So we used that and we kept pushing and pushing on the different systems. And I'll talk a little bit about how that worked, but we ended up installing a 120 kilowatt array for the building itself. So we actually squeezed in a little bit more and maxed it out and gave it a buffer space, which I think is really important. Just because you want a building that's, if it's going to be used for 20 hours a day by transient populations all to campus, you want to make sure that you have enough buffer space so that they can do almost anything in the building if it's operated and maintained the right way. So the energy diagram, or this model section that we have, so the walls and roof and basement are all super insulated. We have an air tightness ratio that meets Passive House. This is not a Passive House certified building, but we have met the Passive House standard for air infiltration. Where we do have glazing, it's all triple glazed. So the Schuco product that we purchased for the building, we really focused on the performance within that triple glazing system. And even though the building looks like it has a lot of glazing, we're still within that 40% window to wall ratio, which was really important. The more north you get, the more important that is. So we really have an air source heat pump. It's 40 tons of cooling, and it's much like a system you'd have in your house. It's actually split between the 2 halves of the building, like lungs. We have an east and a west, and there's 20 tons on each side. And really that just that does all the temperate control in the building. We have 100% of our energy is being generated from the roof on PV solar, on a PV photovoltaic array, excuse me. And there's sun power panels, very high output. But what we're finding is that the performance of them is so consistent that we're actually exceeding what we should have been monitored at for energy production. So that's really the system. It's much like a big house. So we have I think we have 8 energy recovery ventilators up in the attics, and we have a small series of ducted heat pumps and also just wall evaporator heat pumps. And it's very simple, very easy to maintain. And that was another part of the project that was really important, is that we can't have a system that's too complicated that doesn't get maintained. And with campuses that are, small college campuses in New England, they're not sitting on endowments like some of our other larger institutions. And they really need to be nimble with how much they spend and how they're able to keep up with their building. So this was also a recipe for us to maintain sort of a level of simplicity in the system that could have parts changed in and out almost. And state-of-the-shelf technology was something that we talked about a lot with the client. So you don't get the performance without really thinking about the wall assembly, thinking about having whatever walls you have, separating the thermal bridging and maintaining that. We also decided for this system that we wanted to try to do our envelope without any thermoplastics. So we're using 100% blown in dense pack cellulose for the project everywhere, even in the attic. And we were able to maintain a strong envelope performance without any thermoplastics, which was very exciting. This is what our energy profile looks throughout the year. We're about 15 to 20% over what we use. This was the first and second year. It's pretty similar. If you've never seen PVs, installed flat with the roof, this is what that looks like. But this is the business end in the basement for the PV. I believe it's the bank of converters that change it from DC from DC to AC so that it could be used in the building. A little bit about the facade design. We're using operated adjustable shades that change throughout the day and throughout the season. They're programmed for solar gain in the building, but they're also just reflecting and seeing the weather as it comes. It was really important to have us also maintain a level of transparency at night, so everything can retract when the building wants to go into sort of a cooling mode from that day. I'm going to zip through water very quickly. A lot of our design challenges were actually in the site water for the project. The infrastructure required to do the living building challenge systems for gray water and rainwater collection basically managed and it drove a lot of our landscape design. And that was something that was more of a pressure on the design team than we originally thought. But we ended up looking at, if you think, as you go up on the plan, the site goes down. So up high, you're collecting, and the cisterns are collecting. We're collecting about 10,000 gallons each. I'm sorry, 10,000 gallons total. And part of our water budgeting was the same way that was similar in how we processed through the energy modeling. And we really wanted to get it down to about 100 gallons a day. In standard buildings, you're using way more than that. In the Kern Center, we wanted to hit that much lower because all that stored water was going to, there's dollars associated with the water storage. And in the proposed design, we kept it below about 150 gallons a day. The big part of that was using composting toilets to remove waste from the water use, which is really important. I'm going to skip through some of these pretty quickly, but the gray water design was really an integral part to the ground floor experience, where we really wanted to have people understand the system that was working, and they could go down to the basement and look at the gray water treatment, but then experience it as part of the architecture on the ground floor. Composting toilet, these are about the size of a smart car. We have 2 of those in the building in the basement, and they're really just maintained, once or twice a year. I won't get into the regulatory path too detailed, but just so you know, it does take about a year to get the permitting done for both the rainwater harvest and the gray water for this system. In the material palette, we wanted to go as local as possible to keep our embodied carbon down. And also with the choices that we were making, we basically tried to make the building lighter and lighter by reducing the amount of concrete or any other heavy materials needed. 100% of the building materials are healthy. They're all registered and vetted and able to be found on the ILFI's website, and I can make it available for people as well. So the stone comes from 25 miles away. The wood we talked about already. And then we used a lot of reclaimed wood from other products, from other projects that were being decommissioned. And we did develop a hybrid solution to maximize the insulation, but also, use the right wood product in the right system. So there's a superstructure that slips inside of a stick-built hull that we used. And that was a system that we developed with these wonderful craftspeople who came down from New Hampshire to work with us. And I'll also say that a big part of the process that we had was thinking through the details with the craftspeople that were actually going to build it. And the results that we found were really, it brought our design level up another notch, working with the people that understood these materials so well. A little bit about the process. There's a 2-stage. I can answer some questions about the Living Building Challenge process. In the end, it was a 4-year process, and the project has been certified now. I believe we're in our 3rd or 4th year of operation, and it's been an honor to present it to all of you today. Thank you.
Beautiful. Thank you, Jason. All right, our last presenter is Jenn Wampler and Jason Fierko with EwingCole on the Unisphere project. So again, if you have any questions, just enter them into the chat. After this presentation, we'll open it up to a Q&A.
Hey, everybody. Jason and I are going to be talking to you tonight about United Therapeutics' latest building in their corporate headquarters, which is located in Silver Spring, Maryland. For those of you not familiar with that area, that is northeast of DC. This building, dubbed Unisphere, is a 6-story office building, and it is the largest site net zero commercial building in the US. It is LEED Platinum certified, and just last week we received our LEED Zero certification as well for net zero energy. Before we dig into the project, just a little insight into who United Therapeutics are. Their CEO is Dr. Martine Rothblatt. She is a very inspirational genius. She founded the company because her daughter had a fatal disease when she was a child, and she formed this company to save her life. And about 25 years later, her daughter's doing very well. So a great story to research and find out about her if you're not familiar with Dr. Rothblatt. But our presentation is about the building, not her. But she was very involved with the design process from the outset. And she was the one who handed us this net zero goal. And said that not only does this building need to be net zero, all of your energy needs to be generated on site as well. So she really started the project with that high level support and her vision, and made sure that we had buy-in at all levels, from the CEO to the facilities group, which really encouraged the architecture and engineering team to give that early buy-in as well.
Yeah, and I think the other important thing to know is that this project was started in 2011 when there wasn't even a definition for net zero, really. And one of the things that was interesting about Unither that we really adopted on this project was their culture of yes. As a biotech company that specializes in bringing technologies to market that haven't even been invented yet, they don't really take no for an answer as kind of their corporate philosophy, and that extended to our design process. So there was a rule that whenever you went into a meeting with Martine, you could not say no. And believe me, there was a lot of times we wanted to say no. We were trying to design the largest net zero building in 2011 when that really hadn't been done yet. But what we found in retrospect was that that culture of yes really was important to the success of the project, because for all the times that we wanted to say no, when we ended up saying yes, we ended up coming up with a better solution than the solution what it would have been had we just said no. So the culture of yes was really important, and that was infused throughout the culture of the project.
So this image here is looking at Unisphere shortly after it opened in fall of 2018. This is a 210,000 gross square foot building, but when you start to break it down by program, that includes 75,000 square feet of terraced parking, which would be on the left-hand side of this image behind the perforated screen, 5,000 square feet of a central atrium in the middle of the office tower, and then a band of retail around the ground level that's about 10,000 square feet. So what's remaining is about 120,000 square feet of office tower. And that is a 6th floor building in an elliptical shape, just to the north of the parking deck. And again, to just reiterate those initial goals, right? Net zero energy, all renewable on site, which means we couldn't have a rural field full of a solar array. We had to make sure that we could produce all of the energy needed to support this building on the 1.5 acre site that exists in a very dense urban neighborhood. And so in order to support that goal, we also set our goal of a 70 to 75% reduction in energy from the benchmark commercial building. And then, to look beyond the energy, this also needed to be a landmark building on the East Coast. It needs to serve as an exemplar of what sustainability and design, how those two can collide, and that you can create really beautiful, inspiring architecture that tells its story. So not just in the infographics inside the building, but you can walk by this building, not even enter it, and see the solar panels on the facade integrated into the design. You can see these operable windows when it's in natural ventilation mode. You know that something interesting is happening inside this building, and it really exhibits its function within its facade. Next slide. There we go. So taking a look at what this site originally was, the image on the top left is showing the existing site, which was this city-owned, nondescript parking garage that was right at the gateway to Silver Spring. That green arrow shows where all vehicular traffic enters Silver Spring, and they're greeted by this just monolithic concrete mid-century kind of rundown building. So, Unither really understood that not only was this going to be the new face of the expansion of their headquarters, but it also was going to be that gateway, that new gateway into Silver Spring. And so it was important to the community as much as it was to Unither. Also worth mentioning, the two buildings highlighted in orange are 95-foot tall hotels to the south and to the east of our site. Now, the max height that you can build in Silver Spring is 95 feet. So we knew that the shading coming from these two buildings onto our site throughout the day and throughout the year were really going to impact our ability to generate power. And so we took that into consideration when we sited the office tower, rotated it, and got the orientation nailed down. And finally, the last piece was this all informed how much program we could fit. So as we started to evaluate the form of the building, this was an early study that we performed in Ecotech, which I don't think is even available anymore. But what this showed us was that shading we were worried about really was going to hit our office tower. So you can see in the lower image that sort of dark violet color was shading from that southern hotel. But what wasn't getting a lot of shade, or any shade really, was that lid of the building shown in that really bright red. So we took that solar tray and we expanded it. It's actually larger than the footprint of the offices itself. And that's where the majority of our solar generation takes place. And then we clad the southern facade and also the parking garage to the south to get that little extra amount of solar, which you can see here in this plan. Now, stepping into the building, the typical floor has 20 private offices. And those offices are located on the outer perimeter of the elliptical office tower. That's really to get the most daylighting possible, as Jason spoke to earlier. Inboard is the circulation corridor, which circulates around a central atrium. There is a skylight in the center of that atrium, which brings in actually sufficient daylight to light the corridor most of the hours of the day. We then located conferences on the east and west ends of the building. The east end, really, we located those to create sort of irregularly occupied rooms, right? Because that morning glare was going to be a real issue. We then clad the building with a perforated metal screen. It worked as a way to announce the building, but also to block out some of that unwanted sun. And then in the far east end, where occupied space was really undesirable, we actually just converted those into outdoor terraces to create a unique working space. Okay. Next slide, please. So to create this complex design, we really kicked off this building with that first level of goal setting and benchmarking. We then worked hand in hand, engineers and architects, to work through the preliminary design, attacking this from the massing, the breakdown of the envelope and how that was going to work, and also early energy modeling. So you guys have now heard that 3 times, just how important that early energy modeling is. So, every decision we made, we went back and checked it against the model to make sure that we were improving the aesthetic, the function, and the performance of the building. And that really helped us move forward in this concerted path through design, be able to refine our strategies during detail design. And then in construction, we still were checking that model. So, that's when some commercial projects have the risk of kind of going off the rails with substitutions, things like that. Whiting Turner was our contractor. They were completely on board with the mission of the project. And so we modeled every modification that happened during construction. So to show one example of the sorts of modules that we were investigating from early on, starting in the top left corner, moving clockwise, I want to walk you through the design iterations of the typical office space. So we knew that the building was elliptical in form, and we knew that we wanted it to lean. But just how much it leaned and how the solar panels worked with that facade were really critical pieces that we had to evaluate. The solar had to function both as an awning that would help shade the vision glass below it, but they couldn't shade so much that it took away from the solar row below it. So that balance was very carefully analyzed. We then stacked the facade to optimize the envelope. So we have daylighting, and actually the panel below it are a high insulated translucent glass. Vision glass is electrochromic, so that it tints automatically based on the environment outside, and then spandrel below that vision glass. Then below the raised floor, we have operable awnings that brings in natural ventilation, brings the air across the floor and into the atrium, which acts as a thermal chimney to draw air across the floor plate up and out the top of the building. Something that was really interesting that we discovered as we started to run our daylighting models was that the sloped ceiling, which we thought was going to help bring daylight further into the floor plate, actually wasn't helping us. And so we flattened the ceiling and we pushed it as high up against the slab above as we could. So we have 12-foot high ceilings and a 16-foot floored floor. That became perhaps uncomfortably tight to get the utilities through. So we very carefully coordinated that early on, and every discipline bought into the strategies of using branches above the corridor, which had a lower ceiling, and then coming out above the offices only as needed to serve the chill beams and lighting overhead. Then looking at the modeled solution, what we mean by modeled is CFD analysis, computational fluid dynamic, to make sure that the air could actually traverse the office floor. And so some of the strategies that we took after this analysis was to lower the office partitions down to 8 feet. So there's about 4 feet between the partitions and the ceiling for air to flow into the louvers and the grill above the corridor. And we also perforated the front of the office facade so that we could let air move across the floor as well. So looking at that completed office image, the photography there, you can see those louvers at the bottom of the furniture system panels, which we also decided to use for ultimate flexibility. So instead of constructing gyp and stud walls, we use these clear or semi-transparent, I'll say, furniture systems to create the office spaces. You can also see the chilled beams in the ceilings. And we added ceiling fans as well for additional comfort.
Yeah, so one of the main features of the building is the central atrium, and we really wanted the atrium to support the sustainable mission of the building. We kind of wanted everything to really support the sustainability. And so initially we envisioned this as an outdoor space that would be under the cover of the solar tray. And as we began to think more and more about it, we thought we could do something really interesting by passively heating and cooling it and actually enclosing it. And the way we did that was through an underground earth labyrinth, which I'll talk a little bit more about on the next slide. But in addition to that, we took advantage of the height of the building and the stack effect that's naturally created in tall buildings, which we often, as engineers, try to combat. In this building, we thought, well, why not embrace it? It's a naturally ventilated building. We can actually use this chimney to naturally pull air through the building, kind of as an engine for natural ventilation. The third kind of interesting aspect of the atrium is that there is a full regulation lap pool in the atrium, and that was part of the original design directive, and that created a lot of issues from a design standpoint. We didn't have the energy to make this an natatorium, so how do we deal with that? We didn't want to put in, a gas-fired boiler to heat the pool. So what we did was we actually found that the building had an excess of heat over the course of the year. So we used the pool as a heat rejection source. So we used a water-to-water heat pump, and we could actually reject heat into the pool as the cooling source. So that was a nice way to kind of close that loop. Some finished shots of the atrium here. Here you can see the swimming pool. This is with the floor in the bottom position. The floor actually can be raised and becomes a structurally insulated cover that when it's closed becomes a walking usable surface, and also eliminates heat loss and evaporation loss from the pool. On the bottom right, you see the labyrinth detail. So the labyrinth exists about 4 meters below the parking garage. If you walk to the entire thing, it would be about 1/4 mile. There's 3 chambers and a bypass, so we can control the flow of air depending on how much heating and cooling we want to get. The way that this essentially works is we use the thermal mass of the concrete in contact with the relatively stable temperature of the earth at that depth to get us some heating effect in the winter and some cooling effect in the summer. I'll say we've been through, heating and cooling season already. It's worked actually beyond our expectations, so that was kind of a nice outcome. Here's some shots of it being built. It was 1,600 feet of corrugated concrete walls. This was all cast in place, taking 8 weeks to complete. The other feature of the building using the thermal mass of the earth was the geo-exchange system that we utilized for the building. We have 52 closed loop wells drilled on the site to a depth of 500 feet. One of the interesting things about this is the statutes in the state of Maryland at the time precluded us from actually doing this. We could not put wells underneath the building. So Unither, being the culture of yes, said we're not going to accept no as an answer. So they did as what any good Washington bureaucratic institution would do. They hired a lobbyist and they got the law changed. So this building was the first building in the state of Maryland to have geothermal wells beneath the building. And interestingly enough, the second building to take advantage of that was the municipal building in the county that was originally telling us that we couldn't do it. So that was kind of a nice change that was really meant to drive future sustainability in the state.
So this is a look at the solar that we were able to incorporate into the facade of the building. We have just under 3,000 solar panels. About 1,200 of those are up on the solar tray. And to compare, the amount of solar panels that we have on this building could support 105 homes for a year, or we could make 3.8 million smoothies. Or knock out 1.2 million pounds of coal. So, a lot of energy is created here. But, the look from the sky and the way that you feel this building and you experience this building from the ground are two very different experiences. And we felt that it was very successfully incorporated, right, the solar panels into the aesthetic of the building. So it feels very cohesive. And again, that all just speaks to how the engineering and the architecture worked really hand in hand from the outset of the building.
But it wasn't all about energy generation. We did have this very strict energy reduction goal. And so when we started thinking about strategies, we start by looking at passive strategies, which are strategies that use little to no energy, but have a positive impact on the energy performance of the building. And the most kind of fundamental of those strategies is building orientation. So we did orient the building to true north-south, even though the city is not planned on a true cardinal grid. So we skewed the major axis of the ellipse to put the major faces to the north and the south. In addition to that, we incorporated external shading. Jenn mentioned the perforated screen on the east side to deal with that morning sun. On the south side, the solar panels that are integrated into the facade actually double as shading devices for the vision glazing. In addition to that, we took advantage of daylighting. 100% of our regularly occupied spaces in the building are daylit, which really reduces our reliance on the artificial lighting system. And the building does have a natural ventilation mode that, yes, even in Silver Spring, Maryland, you can do that. But, this is Silver Spring, Maryland. It is characterized by hot, humid summers, cold, dry winters. If we were going to maintain kind of tenable comfort conditions inside the building, we had to use some active strategies. So the question became, what are the most efficient strategies that we can use to keep our energy footprint as low as possible? And the geo-exchange system was really the bedrock of that, excuse the pun. But it is really the most efficient way to heat and cool the building. And we found in the post-measurement and verification period that it actually outperformed our energy modeling. The other piece that had a big impact here was energy recovery on all of our air streams to make sure that we're not wasting energy through exhaust. The envelope was also a very important design consideration. Although the building appears to have a lot of glazing on it, it's actually very limited, as Jenn pointed out. We do have an electrochromic glazing system. All of the vision glazing is triple paned. And that kind of white striping that you see on the building is this ultra insulated daylighting panel that gives us great diffuse light into the building, but also gives us the insulating value of a well-insulated wall.
So finally, a couple of slides just to show that user experience. We mentioned that it was very important that the building tell its story. And so these static infographics are told in the voice of the building, which make it very easily to understand. And it's great because there's a lot of tours that go through this building. So from, primary education, children to famous movie directors have walked this building, and so everybody can understand the goals and the function of this building. And then the interactive piece, there is an energy dashboard where you can, touch the screen and see as much information as you would like about the generation and energy use. And it's taking the same information that the building management system creates and the facilities folks are using, and just takes it and translates it into something that's a little bit more understandable. And so that's the story of Unisphere. I hope you agree that we have successfully woven together engineering and architecture and sustainability into a very aesthetically pleasing, sustainable building.
Jennifer and Jason, thank you so much. This was wonderful. And we've got a little under 20 minutes for some Q&A. So we've got some questions that were propagated in the chat during the presentations. And I think I'll go first to Jai Agarwal. You were asking a question. If you want to unmute, you can ask your question about energy modeling. But I think it applies to all the projects. You're asking specifically about the Kern, but
I think you're muted still, Jai.
okay.
Yeah, he's yeah.
All right. So Jai, you were asking.
How about now?
Great. Perfect.
Can you hear me now?
We can hear you now, Jai.
I'm so sorry.
That's all right.
So we in our firm kick around a lot of possibilities, like you mentioned, Safara, Ecotect. So I was just wondering if some of the teams could talk about which ones they had successes with, maybe failures with, but especially in terms of using it during the schematic design portion, what do you think would be some of the better options to go to out there?
So I guess I'll start with that as the engineer in the room. So we started actually in Open Studio for this, and we abandoned that pretty early. The problem with a lot of the schematic, it's a trade-off, right? A lot of the schematic energy modeling programs give you kind of the quick thing that you want to get you an idea of where you are. But then you usually have to transition to another program to really get the detailed analysis that you want later. And then in addition to that, we're doing design calculations on the building, which could be in a different software altogether. So we ended up going to Carrier's HAT program, their hourly analysis program, which is a program that mechanical engineers use to actually size systems and do calculations for the building, but it also has a very powerful energy modeling module in it. And we like that from a workflow standpoint because we can do our load calcs and our energy model all in the same program, and we're using the same numbers. So we're designing around the numbers that the energy model is based on. It also gives us a level of granularity where, we can put in every exit sign in this building. We put in 2 watts for every exit sign because we had to understand what the use was going to be. So HAP, it's not I'll say it's not the sleekest program, and it has some roadblocks that we had to, like, it couldn't model chilled beam at the time when we did it. The next version of it was able to do that, so we had to come up with workarounds. But it gives us the granularity that we need, and it works with our workflow process. But that's predicated on, we had a lot of time on this project on the front end to start modeling it. So we could take the time that it took to actually kind of do all the inputs that we needed to do. The other thing that we did that Jen kind of mentioned was we broke this building, this 200,000 square foot building, down into modules, into like manageable modules to model during schematics. So we started with the office module. We knew that was going to be the biggest one. So that's 150, 200 square foot module. And we optimized that. And we just modeled that, and we said, okay, well, what's the right window to wall ratio? What are the right insulating characteristics, lighting, even equipment? Are people, in 2011, the question was, are people going to be using desktops or laptops? And then on the day that the building opened in 2018, people walked in with their tablets, which was great. They used less energy. So kind of breaking it down into its components was another way that we kind of dealt with the size of it.
Yeah, I think from I would agree. I mean, we had a similar process. Not real exciting, but I would say that the load calculation in energy modeling, and I would say envelope performance analysis through Therm. So we used, maybe for those of you who might remember this, so it used to be called Building Energy 10 or Energy 10. I don't believe it's even a thing anymore. It's been absorbed into other profiles or other programs, but we worked very closely with our mechanical engineers at Kohler and Lewis, and doing the load calculations and chunking out, similar to what Jason was just saying, chunking out the different profiles of usage and checking that with we did our Therm analysis of the envelope in different conditions through the curtain wall, through the stone clad portion, through the wood clad portions, to really understand that. And then we use that to inform the inputs into basically Energy 10. And we use that, that's how we also calculated like what our capacity would be, and using that as 2 data points. So we always knew we had a bookend, right? We knew there was going to be an order of magnitude of usage, and then we were only going to be able to generate so much, right? So there's this, you have to work within that. And we also talked, I think, Jason, you mentioned it too, is that, we looked at thermal comfort profiles very differently in the transient spaces and common spaces as we did the office spaces and the classrooms. So we were able to really do some nice tuning with our load calcs that helped us sort of understand and project the modeling as we went through the design process.
I mean, if I could jump in there too, Jai, and just say that, for a passive house project, we're using Wolfie Passive, and that mostly using the static design software. And there's a dynamic version that dives really deep into hydrothermal modeling throughout the course of a year. You can focus on comfort in one apartment unit, things like that. But mostly it's the static modeling software. And I have to say, it's interesting to hear how like a medium and large project are dealing with energy modeling. It sounds like it's, in some ways it seems like I thought it might be a little bit more figured out or something when you get to that scale, but it's similar. It's not as granular as you want it earlier on. And so you have to like make these big decisions and hope it lands in the right place. I think a lot of it is gut checking too. And it's interesting for me to see larger projects. Like I'd love to hear Jason and Jenn talk about, like I just look at their projects and it's like, that is a lot of glass, right? We could never do that and hit passive house, and then it's a lot of solar panels. And so I think that's interesting to see the different approaches between passive and active measures, right? And I don't think there's anything that like really solves it, but we're taking different measures. There's internal gains to think of, and that changes wildly on a tiny project like ours to a huge project where there's all kinds of internal gains, heating the thing from the inside out, right? So the envelope maybe matters less. So I just think in terms of the smaller it is, I think you have to make bigger decisions about the envelope from a gut level and an early modeling level. And I actually think Wolfie could do that well if you know how to use it, because we can draw a 2-dimensional plane with no windows and kind of draw a massing model and run it through the system. You can do that in SketchUp, and it will tell you how, the primary energy demand, all this stuff, and you can kind of begin to tweak the model that way and poke holes in that box, if you will. So I actually want to go back on what I said. I think actually could be a fairly iterative tool. I just wish it was a Revit plugin. That's what drives me nuts. And I think all the other architects and engineers might say the same thing, that when you're hitting the keys in Revit, it would be nice if you just had a constant iterative update. But what are we, 10 years out, 20 years out to that? It's mind numbing that we don't have that yet. That's what's frustrating.
Well, it is there. It's called Insight 360. And that's ideally Revit's built-in schematic energy modeling tool, but none of you have mentioned that, which is really interesting.
Yeah, we have experience with Insight, and we're not there yet with it. I'll just leave it at that.
Yeah, I think
Sure. It sounds
Grove tool is probably the closest thing
Yeah.
for early design from the architecture side. It is with a couple of little bit of setup, you can easily export out of Revit, and it's very informative early on and iterative. And I know that they've been constantly adding more tools this past year. So I would say that for architects, that's a useful tool.
So I'm going to switch to one of our other folks' question. Kit, do you want to unmute yourself? Had a question about
Yeah. Which
Client
question? I think
and
I
the
may have plugged in
the
a few
one
of those.
about clients getting them on board
Yes.
with the aspirational energy and environmental goals. So
Yes, so I think I definitely appreciate all the presenters and applaud kind of the level of sustainability achieved in all these buildings. I think it's goes without saying that you had clients as well that were extremely interested and bought into these aspirational environmental and energy goals. So I was wondering, along the design process and through rounds of costing, did you ever find either moments of conflict where either costs were greater than maybe the client expected due to some features, or were you able to justify this? How were you able to justify those costs? And then maybe how did you approach some of those conversations to keep them engaged and interested and not shy away just based on cost?
I mean, I'll just start and say that our client came to us with this idea, so that's a real gift, and that's pretty rare. You know, in 10 years doing this, that doesn't happen every day, right? So it's a gift. The clients are a gift, and I know this is being recorded, and I know he'll listen. So, that plays into it too. He's great. So, but beyond that, he also had a lot of doubts, and doubt, I think, is a normal role throughout the process that has to be. You have to let people vent. He's very frustrated, like. At these, we have to be promised about not over. We have to be careful about not over promising some of these newer technologies, which are a little clunky when they're the first and second time around. And so he was able to vent that stuff, and we were able to remind him that yes, you could have stick framed this, but it's not nearly the quality, and it would not have gone as good, because I've seen it, right? So I think like you have to just let clients have their doubts and then just work it out and create a culture where that stuff is safe. I think it's pretty simple, and if they end up not wanting to do it, well, they're just not going to do it, and they're going to move away from it. But I think that as long as you can show them the data, that's important. It gets back to modeling and continue to talk about your experiences with other things that will not meet their goals, right? I think experience helps for sure.
Yeah, I mean, the client engagement is the most important thing. I mean, in my experience, if you're having to go to the client and convince them to do this, it's probably not going to happen. If they're coming to you and saying, this is something we're really interested in and we really want to do, then there's a good chance it's going to happen. I agree that, the modeling is important. That becomes a tool for showing what the energy savings can be, and understand that the payback analysis in a net zero building is different. If you are going to make the commitment to go net zero, we could look at, okay, well, what if we do LED versus fluorescent, right? That was a discussion back when we were designing, right? There was a cost premium at the time to do LED. It saves us so much money, which actually translates into solar panels that I don't have to buy, which are the more expensive technology, right? So it's not, does it just pay back for itself because it's a more efficient technology? It's what is the solar panel cost that I'm offsetting with this technology. So that changes the way that we traditionally think about life cycle cost analysis. The trouble that we're actually seeing is that the cost of solar panels drops so much that you begin to see people making decisions that are less energy efficient because it's almost cheaper just to put more solar panels on the building. At Unisphere, we didn't have that option. I mean, we used every square inch of the building that we could to put solar panels on it. But we do see that trend, and that's a little troubling because it kind of gets away from, I think, the core intent of doing high performance in net zero buildings. But it's a different way of thinking about payback.
Yeah, I mean, I would agree that we sort of frame that discussion in the total cost or whole cost of a project. And I think that resonated with the client. And we did have, I mean, whether it's doubts or just, there were many times that we were not sure we were going to be able to hit the marks on budget. I mean, our budget was, oh, by the way, do living building for the same cost as any building in a campus in New England for $425 a square foot. No buts, no changes. That's what our budget is. And, when you're looking at a glazing system that could cost 10% or 8% of the project in construction, those were like really big conversations that we were having. And to get to Jason's point and Jen's point about, we were adamant with them that we were not going to let, the energy slip, right? We were not going to let them start to get like, well, yeah, we could do a less expensive wall system and then you can get more solar panels and put them on the yard. That was something that was, it's a slippery slope with a client because it can push sort of, upfront costs to deferred costs that happen much later, and then they can still have the same result. we did have significant leadership from Jonathan Lash at Hampshire College. There was no time that he ever said like, no, we're going to waver. We're wavering on the goal of going living building challenge. That never happened. I mean, it was remarkable at how, there was always discussions and sort of doubt of how to get there. And, we'd never done living building challenge before. So we were also in that sort of incubator of what's possible. And it was just remarkable that, yeah, there was doubt here, but up top, we knew we had this upper level of support that was like, well, guys, that's the goal. So what are we talking about? Like, we kind of know what we need to do to get to that goal, and that never changed.
So to our presenters, at some of those moments where you've got these difficult conversations about, the cost and the energy performance, I just think back to, presentation I saw from Payette a little over a year ago about one of their lab projects where, the contractor comes in and says, well, I can save you $800,000 if we switch from triple pane to double pane glass. But in their integrated design process, working with their engineers, they knew that they were able to size systems based upon loads, which were predicated on the performance of the envelope. So could you maybe unpack a little bit of, how energy modeling and data that sort of like drove those, engineering decisions sort of play into how you unpack this for a client to make informed decisions?
Well, I would just say that I don't think you should be doing this when you're at this sort of level where you're actually making claims like carbon neutrality or something, which is a wild claim to make, folks. It's so crazy to say this stuff out loud, but I think it's also trying to push even us, folks doing this work. We gotta get there, right? We're not there yet. I really have come to believe that it's critically important to actually use a green building rating system. And I know this goes without saying, but I think there's a lot of folks, and myself included, who have done this on the cheap for some family and friends or myself, and said, I know how to do this. But like, if you don't have a touch point to come back to remind a client, especially an institutional client, I would imagine, to say, we agreed on this a year ago, and now here we are in the middle of the process, and someone just in an inflammatory remark says they can save you money. You have to look back to something and point to it, right? You have to say, we agreed to agree to do it this, and that is going to pull the bolt out of the thing, and the thing's going to fall apart. But without that, without at least the touchstone of like saying we have to hit Passive House, or we have to hit LEED Zero, or we have to hit Living Building Challenge, and we won't, right, then chances are they're going to make that $800,000 save, and then you're going to have a building that doesn't work.
Yep, I'd agree with all of what you said, Jeremy. Having a certification or having a metric that you're following, and if everybody's in lockstep with that, we always pulled up the sheet with 9 goals. It kind of got ridiculous. We're like, so we're going to miss these 3, guys. If we make that decision, I'm not saying whether we should do it or not. I'm just saying we're not going to hit these goals. And people generally, I think, when presented the information of all sides, right, not just one soundbite, if there's a good structural leadership process in that team, then the right decisions will be made. But I agree, it is a slippery slope. But I would say from the standpoint of making those trade-offs, we had a couple of those where it was like, because the timber, the engineered glue lambs, they were not inexpensive, right? That they're highly tuned, engineered pieces of lumber that are coming from a distance, and they cost a lot of money. That was a big number for our contractor to absorb. And then say, well, we could do it another way, or we could do it this way, we could do it this way. And we said, okay, well, let's test it. And I think that's the other part, is that when we teach, younger architects and thinking about, it's like, don't reject an idea on the table. Like, absorb the idea. It may not be a good idea. It may not be the right path, but you should give it some time so that you can train yourself to think through those processes, because you might learn something from it, even though it's sort of a non-starter for meeting the goals. I think having an elastic, sort of an elasticity of thinking, it also brings more people to the table, right? So if somebody's bringing ideas, they may not be solving the rights, all the goals or all the issues that were on the table, but at the same time, then I think you could solve more problems with more people generally. And it's trying to be inclusive in that process, even in those tense meetings where I could save you $1 million if you do this type of, strategy.
And to build off of that, I think, this culture of yes and just thinking like, well, no, we're not going to add a lap pool to an atrium, right? That's not conditioned. The answer was yes. Now let's figure out how we're going to make this work. And, as sophisticated a client as we had, there were certainly some requests that were made that made us very uncomfortable. And Jason and I spent a lot of time researching products that would help us solve those challenges and the systems that would help us solve those challenges. But to your point, Jason, right, keeping that open mind and evaluating and studying these opportunities, whether it's a client request that sends you in one direction, or if it's a contractor saying I can save you money. I guess for us, that instead of the list of 9 goals, it was the energy model, and we did look at going from triple pane glass to standard IGU, because we had operable windows and it was very heavy glass to have to operate, and the mechanisms to push those out, because it is automated, that was going to be a cost implication. Well, the cost of energy, to go from triple pane to standard IGU would not have been manageable for us on the project. And so we used the energy model and energy balance as our means to check those suggestions when they came up.
Yeah, I mean, the discussion we had on this building was, well, if you want to use double paned IGU, then this is how much square footage you have to cut.
Right.
I mean, it was that simple. And as an aside on this, to show how serious they were about the goal, Unisphere could have built another 100,000 square feet on this site, and they chose not to, because it couldn't be supported by the net zero goal.
That's accountability, right? I mean, there's accountability in those decisions. And we had similar, like we drew a plan of the Kern Center half the size. If this is the path that we want to take with the envelope, this is what you can build.
Yep.
And it didn't meet their goals. And I think, but again, not turning it down out of hand, doing the work, right? Because then we're often asked to be the thinkers, and the work will present itself, right?
Well, we're past our 7 o'clock time, so I want to be respectful to everyone's time tonight. But we're so appreciative that you all could participate in tonight's event. To all those that have joined us, we've recorded this session. So after this, we will be sharing out the recording, which will be available on our Vimeo channel. If this is your first event, please put your name and your email in the chat window. We use that to get this out to you. You can follow us on Instagram at AIA Philly Coat, and you can also send us an email at aiaphillycoat@gmail.com if you want to get more involved with our efforts here. So thanks again for everyone. This was wonderful. We'll share out as well in our email about some of our prior sessions, which tie into a lot of the topics that we talked about tonight around energy modeling and tools. So